Next topic is plane. The definition of plane. The plane is a surface such that the straight line in joining any two point on the surface lies wholly on it. So very simple definition. That is, if we join any two points on that surface, and if the line joining that two points wholly lies on that surface, then we say that the surface is a plane. That is, all whole line means all the points lies on that line lies on the surface. Then we say the surface is a plane. So it is a day-to-day life definition. Plane, when we say the surface is plane, if we take any two points on that surface, and if we join the two points by line, and if the line wholly lies on that surface, then we say the surface is a plane. So the different forms of the equation of plane. The first form is the general equation of plane. So question is, prove that the linear equation in xyz, that is ax plus by plus cz plus d is equal to 0. This is the linear equation. The powers of x, y, z are in each term is 1. That is linear equation. This is constant term. So ax plus by plus cz plus d is equal to 0 is a linear equation in x, y, z. Represent a plane. This equation, we have to prove this equation represent a plane. Like a linear equation in x and y. Represent line. What is that? Ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0 is the linear equation in x and y, and this equation represent line. This is the equation, linear equation in x, y, z, and this represent a plane. We know that the quadratic equation in x, y, z represent ellipse, hyperbola, parabola in x, y. We know that in the x, y, the quadratic equation, okay, general quadratic equation represent conic section. Like that, this is the general equation, linear equation in x, y, z. So we have to show this equation represent a plane, or this is the equation of plane. So let ax plus by plus cz, numbering it as 1, be the equation of the surface. We have to prove that this is the equation of plane. So let px1, y1, z1 and qx2, y2, z2 be any two point on the surface 1. So in order to show this equation represent plane, we use the definition of plane. That is, when the surface is called plane, if we take any two points on that surface, and if we join the line, the two points by line, straight line, and if whole that line wholly lies on the surface, then we say the surface is the plane. So first, now we have to show this equation number 1 represent a plane. Now we use the definition, that is, take any two point, suppose p x1 y1 z1 and q x2 y2 z2 be any two point on the surface, and we have to prove now that this line pq lies wholly on the surface 1. That is, each point lies between p and q, or lies on the line pq, lies on this surface 1. So there are infinitely many point lies on the line PQ. So take any point on the line, that line PQ. Let R, X, Y, Z be any point lies on the line PQ. And now we have to show this R lies on this surface AX plus BY plus CZ plus D is equal to 0. Okay. So we have to show this point lies on this surface means the coordinate of this point satisfies this equation. So first we will find the coordinate of this point R. R is any point lies on the line PQ. So R is like this. Suppose this line, this point R divides the ratio divides the line PQ in the ratio m/s to m. Okay. Now this point P and Q lies on the surface Ax plus By plus Cz plus D is equal to 0, and therefore these 2 points satisfies this equation. That is, we have A1 we have ax1 plus by1 plus cz1 plus d is equal to 0, equation number 2. After this, writing this same statement, that let p x1 y1 z1 and q x2 y2 z2 be any point lies on the surface 1, write this, that therefore we have, what we have, ax1 plus by1 plus cz1 plus d is equal to 0. That is, this point x1 y1 z1 satisfies this equation. Also this point x2 y2 z2 satisfies this equation. We have ax2 plus by2 plus cz2 plus d is equal to 0. So after writing this statement, write these two equations. Then write that let R be any point on the lies on the line PQ. Suppose R divides the line PQ in the ratio M as to L. Suppose the next sentence is what? After this statement, write the statement that suppose let R divides the line PQ in the ratio M as to L. So write this line R divides this ratio, in the ratio. This point is P. Right, the coordinate of P as x1, y1, z1, Q as x2, y2, z2. And therefore by section formula we have x is equal to, that is x coordinate is what, mx1 mx2 plus nx1 divided by m plus n, mx2 plus nx1 divided by m plus 1. Y is what, my2 plus ny1 divided by m plus n, and z is what, mz2 plus nz1 divided by m plus n. So write x, y, z by using section formula. And these are the coordinates. Now these are the coordinate of the point R. Now consider LHS of the equation, ax plus by plus cz plus d is equal to 0. And then write as x as this coordinate, mx2 plus nx1 divided by m plus n, that is the x coordinate of the point R. Then b, write the value of y as this, and the plus c, write the value of z as this, plus d is equal to, so m plus n is the LCM. So we have a mx2, right, multiply by a, multiply by b, we have these two terms, multiply by c, we have these two terms, plus d in bracket m plus n, because m plus n is the LCM. So right here plus d in bracket m plus n. The next step is what? Then d in bracket m plus 1 means dm plus df. Okay. Then collect these terms. Take m as common from this term, that is m, write in bracket ax2 plus by2 plus cz2 plus this term d into m, so plus d, take m as common, so plus d plus n, from remaining terms take n as common, so we have in bracket ax1 plus by1 plus cz1 plus d divided by m plus n. And this, the value of this bracket, these two brackets are 0 by using equation number 2 and 3, and therefore we have answer is 0. That is this coordinate of point R satisfies the equation ax plus by plus cz plus d is equal to 0, means R point R lies on this surface, and R is any point on the lies in the line PQ. So we say every point of line PQ lies on the surface 1, means line PQ wholly lies on the surface this equation number 1, and hence this equation number 1 represent a plane. So the next sentence is what? Point R lies on the surface 1, because we have what we have, the coordinate of the point R satisfies the equation ax plus by plus cz is equal to 0. Therefore point R lies on the surface 1, as R is an arbitrary point, any point on the line PQ, and so every point lies on PQ lies on the surface 1. And because the property satisfies for arbitrary point, and so we say it is satisfies for all points lies on the line PQ, and that is line PQ wholly lies on the surface 1, because every point lies on the line PQ lies on the surface 1, means the line PQ wholly lies on the surface 1, and therefore equation 1 represent a plane because of this definition. That is, if we take any two point as P as Q are any two point on the surface, and the line joining these 2 points P and Q wholly lies on the surface 1, and therefore equation 1 represent a plane, and hence a linear equation in xyz, that is ax plus by plus cz plus d is equal to 0, represent plane. So as far as the exam concerned, this general form of the equation of plane is important. So write note that ax plus by plus cz plus d is equal to 0, dividing by minus d. So what do you have? Minus a by dx minus b by d y plus minus c by d z minus 1, d divided by minus d is minus 1, and we shift the minus 1 to RHS and take as this minus a by d as capital A, this capital B, and this is capital C. Then we have, this is the another form of the equation of plane. So this ax plus by plus cz plus d is equal to 0 and ax plus by plus cz is equal to 1, both the forms are same. Okay, so this is the another form of the plane. So in this there are three constants. Next, equation of plane in the intercept form. This is also important, intercept form. Question is what? Find the equation of plane which makes intercepts small abc on x, y, z axis. That is, this plane cuts the x-axis at a distance a, at the plane cuts y-axis at a distance b, and plane cuts the z-axis at a distance c. Okay, so this is the plane. This this triangle is the plane which makes and intercepts small a, small b, and small c on x, y, z axis. As this distance is a, and so the coordinate of the point p, this point p are what? A, 0, 0. This if suppose this is the point q, then its coordinates are 0, comma b, comma 0. And suppose this is the point r, the plane cuts the z axis in the point r and at a distance c, and therefore its coordinate are 0, 0, c. So first sentence is, let the plane cuts x, y, z axis in the points p, q, r respectively, and therefore op is a, oq is b, or is c, because the plane cuts makes intercept abc on xyz axis. Means the plane touches the point, plane touches the x axis. If the point is p, then this distance from origin of the point p is a. Similarly, oq is b, or is c, and then the coordinate of p is what? A, 0, 0, q is 0, b, 0, and c, r, the coordinate of r are 0, 0, c. Let the equation of plane be ax plus by plus cz is equal to capital Ax plus, don't take this equation, take this equation. Capital Ax plus capital By plus capital Cz is equal to 1, be the equation of required equation of plane. As the plane passes through these 3 points, we get, suppose the plane 1 passes through the point P, and so point P satisfies this equation. So don't write this equation, write this equation. So we have a into small a plus b into 0 plus c into 0, z coordinate is equal to 1. And so capital A is 1 by a. Also the point Q satisfies the equation 1. Means we have, what are the coordinates of Q? 0, b, 0. So a into 0 plus b into b plus c into 0 is equal to 1. And so capital B is 1 by b. Similarly, the R also lies on the plane, and therefore we have this, that R also satisfies the equation of plane. So a into 0 plus b into 0 plus c into small c is equal to 1. And so capital C is 1 by c. And substitute these values in equation 1, capital A, capital B, capital C. What do we have? 1 by ax plus 1 by by plus 1 by small c, z is equal to 1. And therefore x by a plus y by b plus z by c is equal to 1. And this is the equation of plane in intercept form. Okay. Next is the equation of plane in normal form. Equation of plane in normal form. So question is what? This is also important. Find the equation of plane in normal form. So let the plane cuts the xyz axis in the point PQR. So show this plane as a triangle, this triangle. And suppose this plane cuts the x-axis in the point P, y-axis in the point Q, and z-axis in the point R. And next sentence is, suppose the plane makes an intercept a, small b, and small c on x, y, z axis. And therefore, OP is small a, OQ is small b, OR is small c, and therefore the coordinate of point P are a, 0, 0, coordinate of point Q is 0, b, 0, and coordinate of C are 0, 0, c. So write that sentence. Then, that is, write these statements. Then up to this. Then write the statement that after this, up to this writing, then let the equation of plane be, and then the equation of plane be x by a plus y by b plus z by c is equal to 1. So write that statements first, that let the plane cuts the x-axis, y-axis, and z-axis in the point PQR. That is this statement. let OP is equal to A, OQ is equal to B, and OR is equal to C. Therefore, the points of coordinate of point PQ are these, and let the equation of plane. Then the equation of plane is x by A, y by B, z by C, because the plane cuts the x-axis, y-axis, and z-axis in the point PQR, and this OP is A, OQ is B, and OR is, that is the plane makes an intercept small a, small b, and small c, and therefore its equation is x by a, y by b, z plus z by c is equal to 1. So write that this statement at this place. Then write this: let ON be normal to this plane. ON is what? Is normal to. O is the center of the origin, and from origin draw a normal to the plane that is perpendicular to the plane, and N be the foot of the perpendicular, obviously. So let M x y z be any point on the plane. So take M as any another point other than N on the plane, and its coordinate be x, y, z. Then join this OM and ON, and then this OM N becomes suppose P in the place of M, right? Then OMN becomes a triangle, and then this triangle OPO, the triangle O and P is a right angle triangle, and angle N is 90 degree. Angle N is 90 degree. Oh, let L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma be direction cosines of line ON. Suppose this ON, normal ON, has the direction cosines cos alpha, cos beta, and cos gamma, and that is alpha, beta, gamma are the direction angles of line ON or normal ON. That is normal ON makes angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Okay, so this angle PON is alpha, because the line ON makes an angle alpha with x-axis. Okay, and so angle, and therefore angle PON is alpha, and this angle N is 90 degree. So in right angle triangle ONP we have what we have, angle PNO is right 90 degree. Therefore we have cos alpha is equal to, cos alpha is what? Opposite side. Cos alpha means adjacent side. ON divided by hypotenuse PO, ON divided by OP. Okay, and that is ON. Suppose this small ON is small p, so let ON, the distance between ON is small p, then P by A. So what we have? P by A. OP is A. OP is E. So we have cos alpha is P by A, and A is P by cos alpha. Therefore, small a is P by cos alpha. Similarly, small b is what? P by cos beta, and small c is what? P by cos gamma. By similar proof, we have this. And then equation 1 becomes, that is the equation, this is the equation 1 right here. X by A plus y by B plus z by C is equal to 1. So write numbering the equation 1 and substitute A as P by cos alpha, y by B as P by cos beta plus z divided by P by cos gamma is equal to 1. Okay, and therefore after simplification we have x into cos alpha by P, y into cos beta by P, z into cos gamma by P is equal to 1, and therefore we have x cos alpha plus y cos beta plus z cos gamma multiplying by small p. So xl plus ym plus zn is equal to P, or x cos alpha plus y cos beta plus z cos gamma is equal to P, and this is the equation of normal form, the equation of plane in normal form, that is Lx plus My plus Nz is equal to P. So what are the LMN? LMN are the direction cosines of the normal to the plane, and small p is what? This small p is what? Is the length of that normal. So if the equation is in the general is in the linear form, that is, or in the general form, that is ax plus by plus cz plus d is equal to 0, if the equation is in this form, then the coefficients of x, y, z are the direction ratios of the normal to that plane. So the note is what? The coefficient of x, y, z in the equation of plane are the direction ratios or direction cosines, direction ratios of the normal to the plane. If the addition of here element are the direction cosines, if there is addition of squares is 1, then they are direction cosines, otherwise they are direction ratios. So in general we say that the coefficient of x, y, z in the equation of plane are direction ratios of normal to this plane. That plane. And this remark is very important, that the coefficient of x, y, z in the equation of plane are the direction ratios of normal to the plane. And the angle between two plane is the angle between their normals. So very simple statement. How you can find the angle between two planes? In order to find the angle between two planes, we will find the angle between their normals. That is, find their two normals, and the angle between that two normals is the angle between the two planes. So in order to find the angle between two planes, we have to find the angle between normals, means we have to find the angle between two lines. And the angle between, in order to find the angle between two lines, we have two formulas in the previous chapter, that are what? Cos theta is equal to cos theta is equal to L1 M1 L1 L2 plus M1 M2 plus N1 N2. Okay, that is the angle between two planes in terms of direction cosines. And the angle between two planes in terms of direction ratios are this, that is cos theta is a1 a2 plus b1 b2 plus c1 c2 divided by root a1 square plus b1 square plus c1 square in another root a2 square plus b2 square plus c2 square. This is the angle between two lines in terms of direction ratios. And in order to find the angle between two lines in terms of direction cosines, use the formula cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Okay, so in order to find the angle between two planes, we will find the angle between two normals, means we use the formula of the angle between two lines. Okay, so in order to find the angle between two planes, the same formulae are useful, that is the angle between two lines. That is, the next problem is of that type, that is find the angle between two planes. So we will see the problems in the next lecture.